So we are going to be working on the distance drive challenge in Vex Vr today. This is the first problem we're working on. And basically what you've got to do is everyone's got to do level 1. So I'm going to copy this and we'll bring it in a moment. And everyone's got to do level 2. And then some of you will do level 3. And what you're going to have to do is you're going to insert the code for level 1, the code for level 2. You're going to figure out the total travel distance for number 2, code for number 3, and then the area for number 3. Okay, so let's just go over to Vex Vr here, and let me see if I can add a note. So we remember what we're supposed to be doing. Okay, can I make this bigger? No, so level 1, program the VR robot to drive forward 3 grids, and how far should you program the VR robot to move if you want to go 3 grid squares. So before we even do this, like some of the things you want to do is we're doing this on the grid map playground. So under playgrounds over here, if you select them, you can select different ones. And we're going to do this on the grid map. So we've got these squares, and what we wanted to do is go forward for 3 grid squares. 1, 2, 3. Okay, so each grid square is a certain distance, and I don't know what that is. But first, if you just wanted to make the robot drive forward, we would just drive this block here and hit drive forward, and then we'd hit play, and it just keeps going because that's all we've told it to do. So I'm going to reset, and if we look, I'm going to see approximately what 1 grid square is. So this is the X and this is a Y, so it looks like we're going to be watching the Y. And it looks like we go from -900 all the way to like 950. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So there's quite a bit of travel in there. So what we can do instead of just putting drive in, we can actually tell it to drive a distance. So we can like go drive forward, and the default distance is 200. So let's see what that does. I'm going to hit play drive forward, and it'll drive forward for 200, and then it stops. And that looks like it is 1 box. So if I had to guess, I'd say 1 box equals 200 millimeters. And it might even say something like that in this thing. Ah, look at this. Each square is 200 by 200. So if we wanted to go here, we could drive forward for 200, or we could add an operation in here, or we could say drive forward for 200 3 times. So either of these would be correct, and then I am just going to stop driving when that is done. So I'm going to hit play. I'm going to hit reset. I'm going to hit play. So 1, 2, 3 boxes forward. So we've gotten 3 boxes forward like it says, and we are all done. I believe in here somewhere too I could even say to end the program, stop project here, and then it would stop running the counter. So if I wanted to, I could say do, and then it would stop the counter. So it's not running anymore. So that is problem 1. And all you would do for this is you would take a screenshot of the code right here, and if you wanted to, you could even get the robot in it, but not necessary. So either or is fine. And I would copy this, and I would put it right into my document right here. I'd just come in, I'd insert the code, paste. Don't care how long it is, but I can see. And if you even want to resize, make it a little more comfortable, that's fine. So that would be number 1. So let's go and see what number 2 is. Level 2. And you all, to get 100 on this assignment, or this problem here, you need to do the first and second level. So level 2. Program the VR robot to drive forward 6 grid squares, turn around, and then drive back 6 squares. And it asks you some questions, and I'm only going to have you answer this one, like, what is the total distance traveled? And you can use a calculator to find out. So we got to go back to the drawing board here. So this time, we're going to drive forward for 6 squares. So I'm going to use my operation here that I brought in, the multiplication operation. Again, so I'm going to do 200 times 6, because that'll give me 6 squares. I could also do the math and do like 200, 400, 600, 800, 1000, 1200. And that will get me the distance I have to go. So I could either do this, or I could write in 1200. So either of these would be appropriate. I'm just feeling like this. Okay. And what I'm actually going to do is I know I'm going to use this code exactly the same again. So I'm going to drag it off. I'm going to duplicate it. So I know I'm going to use that again later. So what I'm going to do next is I am going to have to turn around. And to turn around, I am going to use the turn right or left because it doesn't specify. You have to just turn around and drive back. So I'm going to get here and then I'm going to turn around. Right, so, and I got to figure out how far I'm turning. So like this is basically 0 degrees. See the rotation 0. If I turn 90 degrees, I would be facing this way and I would drive this way. If I want to go exactly back, I have to turn 180 degrees. So that will turn me all the way around. And then I want to drive back the exact same distance, 6 blocks, that I traveled from. So here we go. I'm going to hit reset on my program. I'm going to go up 6 blocks. 1, 2, 3, 4, 5, 6. We're turning around 180 degrees and we are going back 6 blocks. So there you go. And I stopped there because we ran out of program. I didn't end my project. I could have. In better code, I would. I'm going to do stop project. Okay, so there's part 2. Now, if you're getting bold, we can go to part 3. So let's see, what does part 3 say? Okay. So now, program the VR robot to drive in a square. Each side of the square should be 3 grid squares long. What is the area of the square? And you would calculate that however you want. Oops. Well, I'm going to go paste that in my note, and then I will paste the code for this before I go. And you know what? I'm not even really going to bother to get the robot. It just asked for the code, so that's what I'm going to give it. Sometimes I will ask you for your code. Sometimes I will ask you for a picture. And then you can write down the travel distance in millimeters. So for number 3, let's see. What do we got? So I'm just going to drag this out here. I don't need these two. Now I'm going to do a square. And it says the square is 3 grid spaces long. So 1 grid space is 200. So 3 grid space times 200. And then a square means I'm going to do 90-degree angles for that. So what my square should look like, if I get my pen tool out here, if it'll work. Holding on. There it is. So what this square should look like is I should be going up 1, 2, 3, over 1, 2, 3, down 1, 2, 3, and back over 1, 2, 3. So if everything works, I should travel along this path I just drew on my screen. And I can't actually move this now because I drew that on top of the screen. So this has to kind of stay here. So what I'm going to do is I'm going to try to save myself some time. So I know what I have to do is I have to drive forward and then turn, and drive forward and then turn, and drive forward and then turn, and drive forward and then turn. And it's basically just this code 4 times. Now I have some ways I can do this. The simplest way would be to do this. I'm only going to turn 90 degrees each time, and then to duplicate, and then duplicate again, and then duplicate again. And that should put me back in the same spot. So this is one way to do it. And let's see if that actually works. So we're going to go up like this. Boop. Boop. And we're following that box I made. Great. So this would be the code for that, and then you could calculate the area. And look, I didn't even need technically this last box, but it made it turn back to the way we started. So that's kind of cool. So I'm going to erase that. Okay. So I got all this in here. I could then copy it in, Everyone should have the right answer now. And just copy that in. And you guys got to do the minor calculations. So paste that code in. Okay. So there is another way to do this. So if you want something a little more advanced, you know, you can stick around. Oops. I'm gonna drag all of this off. And I don't know if this will work, but I can do something called a repeat. And I want to repeat this action 4 times. So basically, I'm saying I want to repeat this code right here 4 times. So if I drag this code in here, it should repeat 4 times. And let's see if we can, in fact, go and 1, 2, follow my line again. So this is like a fancy way to do it with less lines of code. So let's see if this works. So there's 1. Here's 2. Here's 3. And here's 4. So this is something we're not really up to yet, but it is a nice additional piece of code. So we're going to stop right there. And we are going to have the ability, if you wanted to snip this, would also be acceptable. There are lots of right ways to figure these programs out. I hope this was interesting and helpful. Good luck calculating the distance traveled on the one problem, and also good luck with the area on that final problem.